Hello everyone, my name is James Blackwell. I'm doing a PhD split between physics and applied maths. My research involves finding brain tumours using ultrasound. When you think of brain surgery, you probably imagine something a bit more advanced than the surgeon taking their finger, having a poke around, trying to find the right spot to cut out. Unfortunately, this is still the case. The reason for this is even though we have fantastic imaging techniques, such as these MRI images here, which are used before surgery, and the brain tumour is easily seen highlighted in red. During surgery, when the skull is removed and the brain is exposed, it deforms, it changes shape. So that means these excellent images before surgery are no longer as useful, and the surgeon is effectively flying solo. Brain tumours are stiffer than the surrounding healthy tissue. So the surgeon takes advantage of this by taking their finger and having a poke around, finding the stiffer area and cutting it out. As you might guess, this is not an exact science, and I'd like to improve on this. So my research involves creating stiffness maps of the brain using ultrasound shear waves. So what is a shear wave? What I'd like you to imagine is a stone being dropped into a still pond. You get an initial splash, and ripples come out. What I'm doing is I'm taking two ultrasound beams, focusing them to a point. This creates a splash in the brain, and the ripples that come out are my shear waves. Now, what's interesting about these shear waves is that they move really slowly. You can see them move in real time on screen. And the key thing about them is their speed depends on the stiffness of the material that they're in. They'll move faster through a stiff material and slower through a softer one. So by watching the shear waves and tracking their velocities, I can then create a stiffness map. So currently I'm just in the simulation phase and I'm testing on fake brain tissue. But I'm going to move to pig brains, to cadavers, and then to live brain testing. The end goal is to create brain stiffness maps in real time that can be used during surgery to help guide the surgeon to find the stiffer brain tumours and other diseased areas, and hopefully reduce the need for poking around in your brain. Thank you very much for your time.